Use case diagrams, the simplest graphical representation of what a system must do. Use case diagrams are often used as a communication tool for stakeholders, and it provides a higher level view of the system. Use case diagrams are popular among developers and other stakeholders. However, we will discuss in this video how use cases are often not used to their potential and how they can be abused with bad artifacts. Furthermore, how these misuses can lead to the waste of time and energy. We will explain the difference between use case diagrams and personas, and how use cases and stories are part of use case diagrams.
I don't know.
Use case diagrams belong to the Behavior Unified Modeling Language Diagrams family. The use case diagram represents the interactions of users with the system. The users are defined as actors, and their interactions are called use cases. The use case diagrams are an excellent tool for breaking down a system in stories, revealing the interactions among the stakeholders and converting them into personas.
I don't know.
Persona is more than a user. It's a fictional character that tries to define a public image of one's personality, a certain demographic stereotype that will help to solve software architecture and design questions.
To understand use case cons, it's important to link them to various concepts. Let's start with the use case. Use cases usually have unique names that are short active verbs linked to system behavior. The naming must communicate purpose and should begin with a verb. One should not specify the use case names that implies implementation choices, but should specify desired behavior. Use cases should never be named from the actor's point of view, but the system, to avoid customers not understanding the use cases and creating confusion for developers. Use cases are not object-oriented. Each use case includes features of multiple objects and classes, so any decomposition of use cases scatters features of objects and classes. The tracing of use cases to objects and classes is one-to-one. This provides little guidance to object identification, classes, and the interaction. Use cases ignore the encapsulation of attributes and operations into objects. Encapsulation basically hides the values or state of a structured data object inside a class, preventing unauthorized parties direct access to them. Use cases, if not defined at the same level, displays inconsistency. The translation of use cases into design and code at lower levels of abstraction is based on informal human understanding of what must be done. This also causes problem when it comes to using use cases for the specification of acceptance tests, because the criteria for passing those tests may not be adequately defined. Use cases are not useful for analyzing and designing functional abstraction. Use cases maintain the links from goals to functional requirements. Broken traceability can impact the end product, especially if changes were made and not documented. An actor in a system can be human, hardware, or another system role in the system. Actors' names should be consistent, practical, and not out of scope. Some systems do not rely on actors' input. A good example is embedded systems, or sometimes one may choose to draw important parts of the system, showing only the actors linked to the system. The undefined actors may give a wrong outward impression of what the system provides in the context of the environment. Flow of events. They basically describe use case interaction from start to finish, as seen with pre, post, conditions, and actions taken. Loss of information in the system may occur if exception and alternate flows are not captured when moving from specification on elements' behavior and its actual implementation. Overlooking system response says use cases may not be of equal value to the user, and also the variation of classes and objects among use cases may lead to functional decomposition. Creation of partial variance in incremental development may cause developers to require more iteration from build to build, increasing maintenance costs of inheritance hierarchies. Scenarios. Scenarios are a set of sequences with each sequence in the set representing possible flow through variation that provide specific sequence illustrating behavior. Scenarios describe a persona's typical workflow and face similar challenges personas face. Anticipated error conditions may occur due to variations or alternative scenarios that are impossible to predict in terms of behavior, since scenarios are usually picked from stereotypes. Organization of use cases. Use cases factor common behavior through association. An association specifies the role that the object at one end of the relationship performs. Each end of a relationship has properties that specify the role of the association end, its multiplicity, visibility, navigability, and constraint. One should minimize on crossing lines. It creates an illusion of conflict or might give the impression of two use cases having similar actions, leading to incorrectness. Generalization is basically inheritance, where one model element, the child, is based on another model element, the parent. It is used in class component deployment and use case diagrams to indicate that the child receives all of the attributes, operations, and relationships that are defined in the parent. Generalization relationship can be used between actors or between use cases, and not between an actor and a use case. The child usually inherits the attributes, operation, relationships of the parents. You must only define for the child the attributes, operations, or relationships that are distinct from the parent. Also, one has to be careful when defining the relationship. An include relationship in which one use case, the base case, includes the functionality of another use case, the inclusion use case. They include relationships that support the reuse. They usually support the reuse of functionality in a use case model. Include also helps with avoidance in duplication of event flows, where other use cases use the functionality of another use case. One has to be careful when using include. It can lead to misinformation. Extend. One use case incorporates behavior of another. This type of relationship reveals details about a system or application that are typically hidden in a use case. When the base use case is defined independently and is meaningful by itself, the extension use case is not meaningful on its own. The extension use cases can access, modify the attribute of the base use case. However, the base use case is not aware of the extension use case and therefore cannot access or modify the attributes and operation of the extension use case. Extend is used as part of a use case that is optional system behavior, as a subflow if executed only under certain condition, or as a set of behavior segments that may be inserted in a base use case governed by explicit interaction with an actor. Multiple extend points can be problematic in instances of priority queues. Most current techniques also do not easily handle the existence of branches and loops in the logic of a use case. Use cases tend to be linear in terms of interaction, and extend tends to make functional decomposition worse. System boundaries should also be constant and well defined. When you look at collaboration between use cases, One has to model the relationship explicitly. One use case may be not realized without another. Avoid showing too many relationships. This tends to create confusion. Another potential problem with use case modeling is not knowing when to stop. The use of concurrency and distributed architecture often makes that the order of interaction between the system and environment is potentially infinite. Another fact is also to avoid too many use cases.
First of all, time consuming. It can take a lot of time to interview people and understand their behavior. If you want a more successful, useful system, you need more consumers to survey. But it will require a lot of time, and stakeholders may not have that amount of time. It also requires a lot of resources, and at the end, the data might be unreliable. It can become costly to the business. Getting this data. The interviewer should be prepared very well and understand the company goals and requirements. He or she should spend enough time on it. Being unprepared can lead to misinformation and mislead requirements. It would be better to hire professionals. Easily outdated. Our world changes very fast, and we should always develop ourselves to catch it up. It's the same for the user persona. Trends change very fast, and most things get outdated. That's why the user persona should follow trends and should be changed according to it. False information. The consumer can give false information in the interview. He or she can pretend to ask someone else. They can feel giving data, answering question can be insecure. The data is unreliable, and the time and resources spent on persona creation can be unwise. It will let a system develop unsuccessfully. Developer and consumer. The consumer may like something and what it is implementing the system he or she wants. However, a developer from the experience can predict it will be unsuccessful, may provide another solution. That's why there may be a conflict between the consumer's wish and developer's reality. Misunderstanding for developers. There is a lot of data in user persona, and some of them can be unrelated to developers. It can be confusing. It's hard for developers to read all data and develop system according to it. It will require time and can lead to misunderstanding. Understanding the whole system. The learning curve can be hard for developer and client. Use case personas are very specific and can hide other aspects of the system. You will need to have a wide understanding of the system to understand small use case persona. Expectation and reality. The user persona we search for the interest of the people, but we don't research if they will be able to buy or use it. We can develop a product according to the user interest. However, if they will not afford to buy or use it, it will be meaningless. Lacking useful data. The user persona created by finding common points. Therefore, there will be too many generalizations. A lot of crucial aspects might be lost. As a result, can't we define the whole picture? Grouping issues. When we define persona and add them in groups, for example by demographics, could lead to misinformation, as other important aspects such as behavior could be ignored. In the grouping part, everything should take care of. Losing one side will cause great problems in the future. And now my teammate Vera gonna talk about the tools which we can use to create use case persona.